In this video, we want to refresh your memory of the definition of the derivative and specifically look at the type of questions they'll ask you on the AP exam and that we'll be asking you on our final exam. This specifically relates to numbers 13 through 18 on your review packet for the semester 1 final. Let's start off by looking at the definition of the derivative. There were two ways that we studied this earlier, and we're just going to refresh our memory of these. In the first one, we worked with this first formula, f prime of a equals the limit as x approaches a. And so in this one, we had a certain value, a here, and then we had another value further along that was x. And when we plugged in a, our y value was f of a. And when we plugged in x, our y value was f of x. And if we were interested in the slope of this line, we would have figured out that the slope was our change in y over our change in x. So we would subtract our y values, f of x minus f of a, over the difference of our x values, x minus a. And you'll notice this formula looks very similar to what we have up here. The only difference is we were looking at the specific case where this point at x approaches a. So this is what we're working with, x approaching a, and as x approaches a, we go from a secant line, which was the purple one, to actually a tangent line right here, and that is what we're finding. So this is the slope of the tangent line. All right. In the same way, we can do this with this other formula. So over here, we have x, and instead of finding another point, we find a point that is a distance h away from x, which means that new input is going to be x plus h. When we plug in x, we get f of x for our y value. When we plug in x plus h, our y value is f of x plus h. And again, we've got this purple line. This is our secant line. So the secant line is in purple. And we're interested in the slope of that secant line. Again, our change in y over our change in x. So we subtract our y values, f of x plus h minus f of x. And we do that over our x values, x plus h minus x. And we notice that those x's are going to cancel out. So the x's are gone. And now we've got the formula that looks just like the one up here, except for up here, we had the limit as h approaches 0. So if I put this dot here, what happens is we take this point and h approaches 0 as this red dot approaches our purple dot. And when that happens, we again get the slope of our tangent line. So again, this is the slope of the tangent line. Now what's really important in all of this is that you remember these two formulas. So now let's try out a problem. So if I look at this problem, initially you might say, oh, that looks like a really scary limit. But the purpose of this problem is to recognize, wait a second, that's the definition of the derivative. If I recognize that that looks just like this, let's just grab a copy of that and bring it over here and paste it in here. I can see that these look just alike. And so if I recognize that, then I'm saying, okay, what I have here is f of x plus h. And I realize that x in this case is pi over 3. So let's go a step farther. This isn't just f of x plus h. This is f of pi over 3 plus h. Minus this is f of pi over 3. Which means that what I'm finding here is the derivative of, and what's my function? I can see, oh, my function is cosine. Derivative of cosine when x is pi over 3. So I don't actually work out a limit. I recognize that this is the definition of the derivative, and I just need to know the derivative of what. So when I work out this problem, I say, well, my function is cosine x. The derivative cosine I have memorized. It is negative sine x. And I'm interested in this derivative at pi over 3. So I take the negative sine of pi over 3. a quick drawing of my unit circle, I can see I'm going to be right up there. That's going to be root 3 over 2, so my answer is negative root 3 over 2. There's my answer. So you'll notice it's a limit, but I recognize it being the derivative, and therefore, and if I figure out which function, I just take my derivative using derivative rules. Let's try another one. Here's number 14. So again, here's my function, and I'm looking at f of 4 plus h minus f of 4. And I can see, oh, my function is the square root function. So this is the derivative of the square root of x when x equals 4. So I start off by saying, okay, well, my function is simply the square root of x. My derivative, I have memorized, is 1 over 2 root x. And my derivative I'm interested in is when it equals 4, which is 1 over 2 times the square root of 4, or 1 over 4. And there's my answer. All right, so let's look at another problem, and this one doesn't look quite the same because we don't have h going to 0. Let's just grab what that function looked like. That was this first one here, and we'll just copy that and throw it in here and just compare what that looks like. Now in this case, we can see our a value is sitting right here. It's in a couple places. There's a, here's a, and this is f of x minus f of a. So if I recognize all of that, I'm like, oh, okay, this is the derivative of natural log x when x equals 2. So I show my work like this. Okay, my function is natural log of x. My derivative of natural log I have memorized. It's 1 over x. And I'm interested in that derivative when x is 2. So there's my answer, 1/2. All right, let's look at one last problem. This is of that last type again. Remember, here's a sitting right here. Here's my function. So I know that f of x equals tangent x. I know this limit is the definition of derivative, so I'm interested in the derivative of tangent. So I've got that memorized as 1 over cosine squared x. And lastly, I want to evaluate that when I've got pi over 4. So I've got 1 over cosine of pi over 4. I'll need that whole thing squared. Quick look at my unit circle. There's pi over 4. Oh yeah, that's root 2 over 2 comma root 2 over 2. So I've got 1 over root 2 over 2 squared. I square that, I get 2 over 4, gives me 4 over 2, or